All right, where's the vocab word for this proof? Midpoint. So find something that talks about midpoint and what type of conclusions we can make when we know something's a midpoint. Do we have a definition? Do we have a theorem? We actually have both a definition and a theorem. So what's the difference? One says the measures equal, one names them congruent. So by definition, to be in the middle, you've got the same amount on each side. The measure on each side of you is equal. But then the theorem has gone ahead and proven that you can say they're congruent. So it depends on what you want to state. Well, if we write it just so, we can use transitive property of congruency and not have to do equals or do replacement. But a lot of students sometimes have a hard time getting that set up. So if you want to do that, maybe try that and then ask me to take a look at it for you. But I'm going to use the definition of a midpoint because I can only use replacement rule with equality, with equations. That satisfies the condition that they're equal in that replacement rule. So what we're going to do is we're going to say, well, let's see, if M is the midpoint of BC, so M's right in the middle, what two measures would be the same? If you want to pause and think about it for a moment, you can. Measure of BM equals the measure of MC. So that's that part of our given. N is the midpoint of EF. Well, do the same thing. Measure of EN equals the measure of NF. And you can again say that in the same statement because it's the same reasoning. We didn't need the one to get to the other. Go ahead and say them at the same time for the same reason. And now we want to replace, but I don't have anything the same. So what's the key here? How are we going to get MC tied to NF, which is what we're trying to prove? I have an MC, I have an NF, but I can't replace with that. Well, lucky they gave us more than that. They gave us the statement that segment BM and EN are actually the same. So not only is BM the same as MC and EN the same as NF, but the measures of EN and BM are equal. Well, okay, I want to replace then, but I can't do that with equal, so I'm going to change this to the measures equal. Measure of BM equals the measure of EN, definition of congruent segments. So what I'm saying here is, what does it mean to be congruent? They told me they're congruent. Well, that means all their measures are the same. So if you know segments are congruent, you can say all the measures of that segment are the same. But there's only one measure for a segment, so we just say that one measure equals. But if we had something with more measures, we could say more measures. Just so happens for segments, there's only one. And now we're going to try to replace with what we have. And you can pick any one of those equations that you want to try to replace. Sometimes it'll work better one way, but I mean, look at the first equation that we set up. BM, that could be replaced with EN. And that would be it. Second one, EN, that could be replaced with BM. And then nothing for EF. Try the third one. BM could be replaced with, and that's the one I'm going to use because I can see a little bit further ahead maybe than you guys can just as you're just starting out, or maybe you're able to see that as well. But this is going to get us there quicker. Measure of BM can be replaced with what else equals BM. So we're replacing this into this third equation. Instead of BM, we could say the measure of MC. See where it says BM and MC are the same? So I'm replacing BM with it. EN equals the measure of NF. That's the second thing we had said. So replace EN with NF. Replacement rule. And actually, I don't even have to use symmetric property, S little YPE, to change the order of this. It's already exactly the order I want. The only thing I have to do is say, well, that's all the measures of a segment. So by showing all the measures of something are equal, we can say it's congruent. That's what it means to be congruent. And go ahead and name them congruent using the definition of congruent segments. You can only use that once you already know their measures are equal to change to congruent or vice versa. And that's exactly the statement we wanted to make, a formal two-column proof.